Hello everyone and welcome to lesson 22 of the FX Masters program. We're going to continue talking on this one about fluids, but not in the rendering side of things. We're still going to use them as fields. In this particular case, we're going to talk about one of the effects from Avatar. We're going to show you exactly how it was done, particularly the part where the Banshee, which comes now, okay, approaches the ash and disturbs the air around it, right? You can see as it comes in and starts flapping its wings, then ash starts to move. Interaction between characters and environment is extremely important. Is one of the things where I put my most attention, and if it was up to me, a lot of the budget and the time, the budgeted time will go into making sure that characters and environments interact and they feel connected. I think because having that mentality in this film made it so successful, right? Considering environments as actors and real parts of the film, right? It's not sets that are static and dead, right? So in this case, we're going to continue. We're going to use a variation of what we did in lesson 21. We're going to use a fluid container as a force and push particles around it. Okay. I said a variation because on lesson 21 we used the character geometries itself as an emitter. Where in this one we're going to try to find a way to extract the velocity of the geometry and use that as a way to emit it or translate that velocity into the fluid's velocity. Using just the character, well, it's useful for many situations. This is just an alternative. I find more controllable, and it gives you probably a more natural result. In a shot like this one, as you can see, I'm focusing on the second part of this of this video. I'm saying where the Banshee is flapping its wings, but at the beginning you can see Jake walking. So you could probably combine assignments from lesson 21 and 22 and try to do something like this. So you have Jake moving around and having an effect on the ash that is lingering in the air, and then have the Banshee come in and finish it. Just so you can combine both techniques, you can probably see which one works best for you. But most importantly is just to balance out the influence of a character like Jake versus a character like the Banshee, right? We need to keep in mind here that the wings of this animal are quite massive, and the amount of air that he's displacing is obviously a lot more than whatever Jake could do. So that his influence on this ash is going to come from further back, where Jake is probably almost close to like on contact, right? I think it's an interesting exercise. That's why I decided to put it on the film. I mean, on the course. I'm sorry, because learning to balance those things within one container, if you manage to do that in a believable way, then probably you definitely got the concept. It's obvious to me, but for what I saw in some of the comments from people that follow me on social media and whatever, it doesn't seem to be obvious. I cannot take geometry or anything for that matter from a company where I worked before and from a film. It's not right. It's not legal. So I'm using this geometry which I bought. This is like a butterfly. So I animated this thing using my very limited animation skills. But I did an animation where this animal is coming in, it's flapping its wings, accelerating towards the end to slow down and land, okay? I'm saying that it's obvious to me but not obvious to the rest because I read some comments when I did the promotional material for this lesson saying that, but it's not a Banshee, it's just a butterfly, whatever. I feel sorry for those people. I'm not talking about you guys, my students, because we definitely have more time together and we continually talking, and well, easily. You understand it. You see the picture. You have imagination. So for those trolls out there on the web, they just think that because it's not a banshee shape, the technique doesn't apply. It's just a bit ridiculous, but um, it's the same thing, obviously, and I know you know that. So this is the closest I found. It has big wings. It's a similar situation. It perfectly translates whatever we did at Weta at home, right? You can do it here. So this is what you will receive on the FTP server. You will get a camera, which is animated as well. You get the animal and the ground plane as a startup scene. As per every assignment that you get with my course, you can do this or a variation of your own. I'm welcome to see other ideas. I think it's also interesting, I think, and important that if you could go back to the assignment with the helicopter. We did it with forces and all at the beginning of the course, but I always said that later on when we get to fluids, you could do something a bit different. Probably as an alternative, I think as an addition to the assignments list, I would like to see the helicopter assignment once again using this technique that we're going to learn today. You will understand better now. I'm not saying that you will discard completely fields and using them, not always. You have to, as like I always say, you have to make your best choice and calculate, the time and the money that you have and all, and decide whether you want to do fluid as a field or just use regular fields. Okay. I'm not saying that once you learn this technique, you will never use a field again, because that's not true. But I will be interested. I will be interested to see the helicopter done again. So to start with, okay, we got this scene. We're gonna do a little bit of a recap on whatever attributes for the fluid container. Keeping always in mind that we're not gonna be rendering this thing. That's the key. I say this because the previous lesson was the first time that we looked at a container, that we talked about it. Even though this is a relatively simple technique, it has a lot of importance on a film. Like I said, air, on a film done correctly, air is a character. Air exists. And this is what you're displacing here. If we would have done this the wrong way, okay, we would have made a mistake, or we would have done it cheaply, or just we didn't care, you will feel disconnected. You will just take away from the film itself, from the story, from the mood of the scene. You will take it away by doing a bad effect. It seems ridiculous to some, but those of you who are committed to this and you want to make the best work possible and you want to eventually win Oscars and all that, you have to think this way. You have to be passionate about this, or it's not going to work. So if you are in a film, if you're doing something on your own, and you disregard something as important, okay, I'm sorry, but I wouldn't be surprised if someone else takes the job, right? Air, it is a character. Air is important, and the last thing you want to do is make a $500 million film, and then have people remember the bad things, or something as in a way, something as easy as just doing this properly, like I said, can take away from this particular moment, which is if you see in the film, is a time of sadness, a time of change, it's a time, there's a lot of feeling going into the scene, and the last thing I want to do is people talk about the ash done the wrong way. I want them to focus on Jake, like I always say to my friends and my family in interviews and all. Our job is successful if it's not noticed, right? Like I said, I don't want anyone talking about my ash unless I want to talk about it in a different situation. I don't want people in the cinema saying, "Ugh." And I'm sure it happens to a lot of you when you go see films, particularly, I'm not saying bad films, but films that are done, with low budgets and all that. Sadly, what you remember, what I remember is just how bad something looked. And I have a long list. I have a long list of very good effects and things that I remember and I reference to in my mind. I always have also probably even longer of the list of bad things and bad effects and things that I don't like. It's both things are important, right? But you don't want to be on the negative one. So give it time, give it effort. The fluid in this situation, which is what we're learning, is not visible on the render. But if it's done wrong, then it's not gonna, the whole effect's gonna fail. So give it a shot, okay? Adapt it as if you want. Like I said, if you want to change the situation, you don't want something animal landing. At least have something that is varying its speed and is varying the amount of air that it's pushing out. I'll leave it up to you. I'm gonna keep this video handy as always as a reference. I'm gonna keep it not running but handy, and we're gonna work on this then. Step one, as always, you have to create a container. So let's go in and do a 3D container here. And we need to deal with the matter of scale. Remember from the previous lesson. Scene scale is important for many things, but it's particularly important for effects, and even more for fluids. Particles, they're more forgiving. They're not really constrained by scene scale and all that. But fluids, as you saw in the previous lesson, as you may have seen from the Effects Power User program already, it's very important that they're the proper size. Otherwise, you're going to be wasting resources. You're not going to get the proper look. It's going to waste time. It's probably not going to simulate correctly without overdoing it. We're going to talk about it more in depth in a second. First of all, I need to figure out one thing. I'm just trying to make my handle here bigger, but I can't. Okay, never mind. I was trying to make my handle here bigger, but I'm working on this new keyboard and I don't really know, but it's okay. Anyways, we're gonna place the container. My advice to you, because you're gonna be dealing first of all with the size of the container itself, not with the simulation. It's easier, and I'm saying that you're gonna be dealing with the size based on the animation, right? So I'm gonna have to scrub the timeline back and forth. If you have to do that and you have the container active, this container is going to try to simulate. It may give you errors, and sometimes Maya could crash. I don't know. I'm not saying it's going to happen to you, but it's not right. I think it's not advised. That if you're going to be scrolling back and forth, then you have that active. So first thing I'm going to do is disable the evaluation of the container. That's not going to change the way I work on the size and all, but at least I can just do this. And I don't waste any time, and I'm not compromising my scene. So, first thing we need to judge is the scale. Very careful with that, right? Everyone, be very careful, because someone, might just say, "Well, I'm just gonna make this thing massive. I'm just gonna make it, the first frame of this animal is over here. I'm gonna make the container being the whole thing." You may have a misconception, say, well, you may be thinking, if I understand correctly, the simulation will happen inside the container, so everything should be, for lack of a better word, contained, right, within this thing in space. So I'm going to have to make it as big as the entire scene. That's not right. It is right and it's not right. It's right to think that, yes, definitely, whatever is inside the container is the only thing that's going to be simulated, calculated, and included into the scene. But it's not right to think that you have to do it for the entire time. If you look at the video, the Banshee, okay, starts on the cut, starts way out here. I will ask you to please look at the ash in the air, right? Look at the ash, and you will see that only when he's really close to it, close to landing, is where he's actually influencing that thing. He's flapping his wings all the way back there. He's not going to move air down here. It's not a helicopter. It's not a jet. It's not a spaceship. It's a big animal, yes, but its influence is not all the way until you get down here, for example. Almost like before landing, of course, but you can see that there's no air being displaced at the beginning. Nothing here. Probably into like this, let's say 1, 2. Probably into the second wing flap is not moving anything. and then at the end, then you can get a big rush of wind, so you get all the particles moving. So with that in mind, I don't need to make a container so big that it's going to cover all the way from the back. So probably I'm just going to grab probably where you go all the way down here. You can see that animation, he speeds up, okay, towards the end to land. So, and if you look, if you know, I'm not a, you know, physics major or whatever, right? Aerospace engineer, nothing. But it's obvious to think that if he's flapping his wings faster towards the end, it's just to push more air down and slow down his fall, right? It's the usual. That's normal. So I'm thinking, well, you know, he's doing his thing here, starting to slow down, and towards the end, speeds up. So I'm not going to worry about anything probably past this point. It's something you're going to have to do on your own to judge it. If you change the example, you're going to have to figure out a way where do I expect to have influence from that air on my particles. But I think, in my opinion, in my shot, I think this height, it's going to be fine. So I'm just going to move my container somewhere there. I'm going to see how far it goes when it lands. So it's going to be down there. Okay, so I'm just going to make my container. Let's start with, I don't know, let's say 30. That's on the width. We need to judge that, but I think based on what I can see, it could be fine. Let me just do 30 here. I'm going to move it down to make sure that it's on the ground. Remember what we said about on the previous lesson. Well, I'm going to repeat it in this one and probably in a couple more. Try to use the floor of the container, the bottom part of the container, try to use it always. I mean, always. When I mean always, every time that you have a floor. So in this case, we have a clear ground plane over here. Instead of using collisions with the geometry and the fluid, then it's easier and cheaper and better looking to use just the bottom part of the container as your ground plane. So I'm going to be placing this eventually, okay, on ground level over here. But I think I'm going to need a bit more height. So I'm going to go back. Yeah, I'm just going to give it a little bit more height. I'm going to make this 15 units in Y. All right, somewhere over there. Okay, let's see. So the animal, let's call it the banshee. This is a butterfly. It's easier to call it banshee. So let's say the banshee enters the container, flapping, 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 slowing down. All right, and landing. I think we're a bit short over here. Just think, but also we're a bit too, you know, I'm thinking that the height is enough to have, you know, it's good to have a bit more than needed, but I don't think we need to judge him or start calculating him at this position in Z. So I'm going to have, instead of making the container bigger, I'm just going to push it forward a little. So it enters the container a bit lower and it lands with a bit of room to spare, because you can see here that I'm expecting to have the camera here, right? So I need to have some sort of leeway so the particles can move around. Actually, I think this is too small, so I'm just gonna have to make it in Z a little bit bigger. All right, it's more comfortable this way. So let's go back. It enters a container, which I think is fine. Goes, 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 lands. And it's good, even if it lands in midway, I think, because it's important, this part, right? Look at the reference video. What you really feel is when the particles rush towards the camera, right? Look. Even if, you know, it stops a bit abruptly here, but you can feel it is when the particles rush towards the camera. So we need to have room here. Remember something extremely important, like particles don't have to be inside the container to live and to be calculated, but the way we work on these things, and I keep referring to the previous lesson, right? If you don't have a container big enough for the particles to move, as soon as those particles try to exit the container, they're gonna stop completely, which means that not only you're gonna have particles that stop in midair if they're in front of the camera, of course, but if you're using streaks, they're going to have particles that disappear. Remember that streaks are visible Okay, or they become longer or shorter based on this velocity, right? Also, you must remember that because we want to have the influence of the container, okay, the influence of the fluid on the particles 100%. But what I mean by this is I want the particles to move exactly how the velocities inside the container are. If I want that, okay, if I want to translate that completely and precisely, I cannot use conserve on the particles. If I use conserve on the particles, then I'm not really getting full control from the container onto the particle. It also means that if the particle exits the container with a conserve of 0, it's going to stop. That's why I'm saying it's going to stop in midair. So I'm saying all this because you should understand that you need to give a little bit of room for these particles to move. I think it's okay what we have. Let's say that we're happy with the size of the container. I think I have plenty of room on each side, which is fine. You have to remember that whatever this animal is going to be emitting, the tendency always for fluids is to expand. So they're going to, even though it's flying towards the camera, it's not really flying sideways. I'm going to need to have to give some room because whatever density comes in or velocity is going to try to expand and move to the sides as well. So this could be all right. Now let's say that we're happy, okay, with the size of the container. The next step is always to decide on the resolution, right? We discussed it briefly in the previous lesson. We still haven't gotten to the point where we're going to be rendering fluids. That's going to take a few more lessons. But we do need to discuss and realize how much resolution I want to put. My advice is just in a case like this where you're not going to be rendering the fluid, we said it before, you don't have to go as high as I said before, like 10:1, for example, on the ratio. It's not really needed. But if it's an important effect, because the scene is important and because the proximity of the particles towards the camera, look, they're right in front of it. Some of them actually go past the camera. So they're right on my face. I need to make sure that I have enough detail. I want to see these particles move independently one from another. I want to make them feel like they have different masses and they have the swirl is affecting them differently and all sorts of things. Right? If I want that, if I want to have this nice little detail in front of my camera, I'm going to have to put some effort and I'm going to have to put some resources into getting this container to look right. And it's not going to look right if my voxels are massive, which is the case. These voxels are ridiculously big. Of course, they're not square. I think it's important to mention this. You can see they're not square, right? What I can see here are rectangles. And we said before, like I said before, that's not recommended. And you will think, well, how come? How come is it it's not square if you have this thing activated here? Yeah. By the way, when I make these pauses, it's just I'm just giving you time to think. Because if I give you the answer right away, it's not really helpful, right? I'm learning how to become a better spokesperson. Not a spokesperson. How can I say a teacher, right? I'm just trying to understand that and trying to make it as interactive as it could be when I'm just the one talking. I have to think like you do. So I give you some time to think. So if keep voxel square is activated, well, how come I have rectangles? And it's a simple answer, but it's something that after I tell you is normal. It's obvious, but until I do, then it's not. The disable evaluation is turned off. So if I disable the evaluation, the container I can scale it. I can do whatever I want just in size, but I cannot mess. Or I could change, but it's not gonna really update the resolution itself. So as soon as I just reevaluate this thing, rewind to the first frame, then I get my voxels back to where it should be. I can see them visible here, but I cannot really see on the resolution itself. I cannot really see the size. It's not right. If you have a base resolution of 10 and you have a container with 15, 30, and 45 on the size, how come? This is not right. Don't worry about it. Don't panic, as I always say. Remember my motto here. Right? Don't panic, but it's okay. They look square. All you have to do is deselect it and probably grab it again, and then you can see it's updated. So nothing to worry about. So what's the ratio that you should be using? That will change from scene to scene. I have seen one particular student from my group, and I welcome new ways of experimenting things, and I think it's good for you guys to try other values and all. But don't put all your money, don't put all your effort, especially don't worry and don't try to create situations that don't exist by adding too much. I've seen someone here go 40 to 1, 50 to 1 on the ratio. Not really necessary. I haven't seen that, you know. And because I haven't seen it, I'm not saying that it's the only way, but it's not, you know, if I've seen it, if it's the right way. It's just that if you have to rely on a 40 to 1 ratio to make something look good, then you're doing something wrong. That's for sure. You know, you're not going to get that privilege on a big film. So if you get used to getting 40 to 1, 50 to 1 to get something look decent, then you have to reevaluate how you're doing things and why. Because on a film, you're not going to get that because you're going to be working on probably on bigger scales or with more geometry, more complicated geometry. All the resources will be evenly distributed between all the departments, and you cannot just say I cannot do this because my 40 to 1 ratio is not, you know, possible here. So take it easy with that. Take it very easy with that and slow down. Learn your way first. And as I said before, don't think of the base resolution as a magic number. It's going to fix everything for you. So it's not a render fluid, so 10 to 1 is not really necessary. But I do want to put some effort into this, so I'm just going to start probably with a 4 to 1 ratio. So to get a 4 to 1 ratio, what do we do? I'm just recapping from the previous lesson. You have to pick the longest of the 3 axes, which is Z and 45. Okay, if you want a 1 to 1 ratio, then you would just say 45, correct? You get 1 voxel per every unit on this thing, so you get a 1 to 1 ratio. 2 to 1, then it's a 90. And you can probably, you should try to follow my advice. So the first few tries, keep your calculator handy. Just close this thing. Right, keep your calculator handy because you need to make sure that you know where you're standing, what you're dealing with. So multiply these 3 numbers. So 90, sorry. Okay, 90 times 30 times 60. We're dealing with 162,000 voxels. Like I said, always, you know, even a cell phone, an old cell phone can do it, so you're fine. Not a problem. I think 4 to 1 will be a good one. So 180 on my base resolution. Once again, let's find the calculator and do then 180 times, I'm doing this, right? 180 times 60 times 120. 1,296,000 voxels. That's good. It's a very low number. Any laptop that you may have could do it fine. And it has a lot of detail. I think it's fine. And it gives you room to go even further after we see. I don't think it's going to be necessary. That's the size of the containers. They're small, which is good because you might get some fine detail. Remember, you're going to be dealing with particles here. You're going to, whatever effect from the container, which is going to be visible, is just going to be on the particles movement and the motion of it. That's going to be the only representation, the only connection you're going to have from the fluid visible, right? So having small voxels will give you a finer detail, okay, on the movement itself. You want a very complicated and intricate velocity vectors in this thing. As I said before, this is going to eat resources from your machine, which is not really needed. So, I mean, having the bottom display like that. I just want you to see what you're dealing with. Compare with the butterfly. I can just disable it again, scrub, and then you get an idea of the size of the butterfly versus the size, the size of the voxels themselves. So you get a lot of cool detail in here. But because it is resources, it's not recommended to keep it visible. So I'm going to go to display, I'm going to go to boundary draw, and instead of bottom, I'm just going to stick to bounding box. I think it's a good time to save the scene, so I'm just going to keep it away. Okay. And now we have the container re-enabled, which is fine. As far as the emitter goes, right, I'm going to be focusing on this one, on the movement from the Banshee, right? I'm not going to be needing this emitter. I'm going to get rid of it. It's okay. They can exist. Fluid containers can be without any emitters. That's not a problem. Just like a particle system can be there without an emitter. Not a problem. So how do I translate velocity from different parts of this object onto the container itself? Lesson 21, we just took the geometry and the container, we created an emit from object, and we had the surface itself become the emitter. Perfectly fine. Now, what I want to use, and it's something that I've been using a lot more, to be honest, is having particles become the velocity emitters. Once you become more experienced and you have more practice in this thing, you find yourself using particles and particles more and more and more for many things. It's just the nature of it, you can control them easier. I know exactly how to place them in the area that I want and the size that I want, and querying velocities and positions and things like that is easy with particles. I get access to collision data or whatever. So it's very cool. I mean, I think it's more powerful than just letting Maya decide with the geometry what to do. It allows me as well to have a low resolution geometry, which still will give me fine detail on the emission. If you look at this, the wings are just squares. They're combined into one object. And it's very low geometry. It's almost like video game resolution, right? That's video game resolution. It couldn't get any lower than that, to be honest, right? But if I place my particles correctly, I can get a nice pattern. I can use the texture that they use for the wings, for example, as an emitter for my particles, so I place them exactly where I need them to be. So it's a lot cheaper. If you were to put the Banshee, the full render resolution Banshee, for example, from Avatar in your scene, and expect to get a proper fluid simulation out of that, forget about it. It's not going to happen because it's a very heavy, polygon heavy model, of course, as you can imagine, right? It's a big film, it's a thing that isn't right on the camera. So you don't want to be dealing with that. You want to, like I always say, you don't want to add more complications and things that slow down your scene that are not effects related. Let the container be the problem. The container will be your problem for sure. The container will be the one eating your RAM, eating your hard drive, eating your time. That's a given. So don't add something else that is not, important or completely necessary into your scene. Is going to make your life more difficult. So having particles will allow me to have this level of resolution, but a lot of control. So with that in mind, what I would like to do then is place particles on the wings. I have absolute control over the quantity, the position, the size. Yep, it's great. So first thing is just to put particles on this surface and have them obviously stick to it, right? There's no way in Maya to extract a polygon's velocity, at least not an easy way, a direct way, something that that is just on a menu, right? It's doable, but it's doable with plugins or external tools. And why would I go that way if I can do it easier in a different way? Extracting particles velocity is a given. Particles velocity is a default attribute on them. So querying that and using that for emission is extremely easy. This is another case where I spend probably 40, 50, or 60% of the time of this lesson just talking and teaching you these things. Once again, I hope you see the value in that, because these conversations, even though it's just me talking, I see it as a conversation between you and I, is what's making this course successful, right? And it's what makes you successful in your job. Understanding. People don't, other instructors don't spend time teaching you how to think. And it happens in every, that was my big complaint in university. That's why I never finished it. I hate it. I hate the system, how it works. You need to learn how to think, and adapt, especially in a field like this one, where you learn a technique, and some of the students just think that they're learning how to create this one effect. That's probably why they see this career as such a unreachable thing, where, do I have to learn how to make every single effect out there? No, of course not. So you need to learn how to think on this one. So placing particles and having and understanding the ability that you have on the ease of use, extracting velocity, which is the key on this thing, is what makes it an obvious choice. Particles are the right way to go. And also, you can see now why I put so much time in making sure that you understand how to emit particles from surfaces, gold them, extract velocity. I hope you see that everything that we have done so far is done in an order that I find that is the best one for you. Me talking right now this and saying, emit particles of the surface and gold it to the surface is second nature to you. You have done many assignments already about that. And I'm sure you never thought, I'll be using that technique on a shot from Avatar, doing something that you thought that had nothing to do with this. And there you go. All right, so that's out of the way. My pep talk, as always. Grab your geometry. It's combining all four wings. I thought it was easier. Very simple geometry. That way, you just have one emitter. I'm going to go to M particles, as you know, emit from object. I'm not going to use M particles, just a regular legacy particles, more than enough. Emit from surface, nothing special, hit create. I don't have to see this, but I'm just going to rename them. Velocity particles. I don't have to see them. I know that I can just grab the particles, grab the wings themselves, and just gold them. I'm going quickly on this part because you've seen this before. 100% of attraction. I don't want them to wobble or move around. I want them to get stuck. Also, you need to remember that you need to activate on the emitter, need parent UV. Okay, and also grab the particles, go to the attributes, and you know that, right? And you should know that in order for you to place them evenly all over the surface, you have to add goal U, goal V, as well as parent U and parent V, right? If you add these attributes but you haven't activated need parent UV on the emitter, you have to. Otherwise, it wouldn't work. Okay, we got that out of the way. Easy, very, very easy. I'm going on creation to make the basic expressions. Let's say the goal V is equal to parent V. If you're looking at this and you're saying, what the hell is he doing? I don't know. Why is he not explaining what this is? Then you're on the wrong lesson. You have to go back a lot. You probably should go back to the beginning. Okay, this is very, very easy for you now. All I can say is goal V equal parent V, goal U equal parent U is just going to make the particles be born randomly or along the surface and just stick to that point. I'm done. Great. Next thing, I'm going to be emitting quite a few particles in here. So I'm going to grab the max count And I'm going to start with 3,000 particles and see how that goes. Actually, well, the max count is on the velocity particles, right? I'm on the particle shape. I needed to do this anyway. So I'm limiting my max count to 3,000. In my emitter, I'm going to grab the rate from 5 to probably, because I want them quickly on my scene, I'm just going to go to whatever. I'm just going to go to 100,000. Doesn't matter. And you should know why that as well. So I'm not going to explain that. I want them quickly. I want them in one frame. So in one frame, I get 3,000 particles, as you can see here, right? You know this. How many particles you should have? Okay, it will depend on how much detail you want to give to your shot. We've done these things before. I mean, at least we have thought of that, and we have understood that the more particles I have, the more detail I get. Think. Spend time thinking. As I spend time talking and explaining how I think, you should spend time thinking here. How many particles do I need? And it's not a set number, it's not a formula that I can give you. It's just a visual thing. Think. What are you thinking? Well, you're thinking that these particles here, every single dot that you see is an emitter of velocity. Basically what you're doing is just, this particle is stuck to a position on a plane. That plane is moving. And because I cannot ask Maya to give me the let's say a UV velocity, probably in the future we will have that in Maya. For now I cannot do that. What I could do is stick a particle to a position in U and V and ask the particle what the velocity is. It's the same thing. But what happens is that if you don't have enough particles, then you get these empty spaces over here. Okay? And they're necessary. Okay, you cannot fill it in. Well, you could, but I think it'll be all an overkill. You shouldn't fill it so much. You should have some spaces. Okay, it's not a problem. But these are like points. It's like you're sampling. Think of it. Every particle as a question. A point where you're asking a question. Okay, I'm here. What's the velocity? Okay, I'm here. How about now? What about here and there? Okay. So you need to have a nice, decent resolution, meaning a number of particles. I'm thinking 3,000 is a bit low, but it's okay to begin with. I'm not quite sure if a ratio of 4:1 on my fluid is going to be enough, as I'm not sure if 3,000 particles is going to give me a correct or believable sample. Probably it will. So it's best to start, like I always say, is to start simple and build on slowly, build it up. So I think it's fine. Another thing you should keep in mind, probably will happen to some of you, is if you grab the particles and you decide, I don't like to see points, I want to see spheres, for example, right? So you go here and grab and switch them to spheres. Okay, you'll see that. Let me just save my scene in 1 second. All right. Okay, I go in one frame and you see this. You say, oh no, it's more than enough. 3,000 particles, look, they're all overlapping each other. No, I need less than that. I don't think Louis is crazy. Think of something. Particles set as spheres, in this case, are just for visualization purposes. They're not really considered as spheres. What do you mean by that? What I mean by that, I mean that what you see here is not real. Maya's not going to consider the outline of the sphere itself for emission. It's just going to consider, it's going to calculate it as a point. There. So 3,000 spheres might look like you're filling the entire wings, and you might be okay with that. Thinking that, you're getting a, correct sample of the entire surface. That's not correct. The velocity calculation and the emission of fluid happens as a point. So you get nothing special, nothing useful from visualizing spheres instead of points. Keep that in mind, okay? But we'll see. 3,000. I think it's okay. All right, get my particles. We need to make sure that they stuck to the surface, which they are. Okay, always work efficiently. If you're dealing with the particle part, and as you can see, if I hit play, then my display is a bit slow. It's because I have my fluid container activated, but if I'm dealing with particles first, why do I need that, right? I can just disable it. And I go back to proper speed. Right? Particles are stuck to the surface, they're moving, they're fine. I should be able to extract the velocity quite easily. How do I connect those particles with the emitter? Simple. Grab the particles, shift select your container, go to the fluid menu, add and edit content. We're going to be emitting from object on this one. It's an omni emitter because they're particles. Apply and close. That's all. Now you get a fluid emitter connected to the particles themselves. Great. Let's change a few things on the emitter, right? On this one. If you're dealing with particles, I will suggest to use probably, it will depend. I mean, in this case, it might not be as necessary, but it could be interesting to use radius per particle. If you try to add it, it will complain to you, telling you that, okay, you want to use radius, but the particles don't have a radius yet. That's what it says here. That's normal. We can add that. We can go into the particles, go in here, in general, and find radius per particle, add it, and we're going to put an expression there on creation because I don't want the size of the particle to change. And do whatever you can. So, you know, we need to probably tweak that later. If the particle is too big, then it's going to fill in the voxel too quickly. Now, I'm glad that I'm doing this. This is one of those situations, right? I just told you seconds ago that if you visualize particles as spheres, then not to do that because Maya is not going to consider them as spheres. Okay, and that's perfectly fine. That's true. Now, if you use a radius per particle, okay, then it's different. It's different in the sense that visualizing a particle as spheres doesn't mean anything. That's just a display. But if you have a radius, then you have to think, you know, use your mind there to realize and visualize how, okay, if I have a point and Maya is asking me for a radius, then that point becomes a sphere. For calculation, you can still visualize it as a point. Keep that in mind. You have to separate those two things. And it's good to start to think that way now because fluids work that way. Fluids have a simulation part and a shading part, and they're not necessarily connected in all aspects, let's say. So you can visualize a point and have a radius and have Maya think of it as a sphere for simulation. Or you can visualize it as a sphere, don't have a radius, and Maya will think of it as a point for simulation. Break that down. Yeah? Keep it one thing separate from the other. One thing is how you visualize the particles, another thing is how you consider them in the simulation. So, what I'll do before I put this, to help yourself, because what's the size you can give this particle? How do you know what's the correct size? I'm going to illustrate it with a little example here. Let's say that this sphere is a particle. I know for a fact that this sphere has a radius of 1. Right? That's default. Radius of 1. Imagine this as a voxel. Correct? So the relationship between the particle and the voxel is defined by the radius of the diameter of the sphere versus the size of the container. So you can see, to make it easier, you see that this particle, okay, feels small, right, on this voxel here. So if you're emitting density, then you're emitting density, a little bit of density in a big voxel. That's perfectly fine. If you make this radius bigger, okay, you make it 5 because you thought it was a cool number, then the relationship between the particle and the voxel changes. The particle is occupying a lot more of the voxel itself. It's almost filling in the volume. So this particle will emit the same amount of density, but it has a lot more surface, meaning it's going to fill in this voxel almost immediately. That's a relationship, and that's how you should think of the radius as a very, very important thing. And the radius of the particle is going to translate into more density or less density depending on the size. So radius, particle radius, and density are connected. So don't throw just a number anywhere. You just don't go in and put a radius per particle and just set any number and just go away and then realize, why is my thing, why so much density if I just lowered it, for example? Or how come I have a density of 100 on my emitter, but I don't see it? Probably your particles are too small. The radius is too small. So keep this in mind. This is one of the situations where probably setting those particles to spheres, could be useful just for understanding what's the proper size you should be using. So I'm going to set them to spheres once again. I'm going to go 1 frame forward. Okay. I'm just going to save it. All right, I'm going to go 1 frame forward and I get this. Okay, these are particles with a radius of 1. Let me try different numbers. This is the fastest way to visualize this. So this is a radius of 0.5, and they give you particles of that size, which I think they're massive for what we're trying to do. I tried 0.1. Let me rewind and forward one more time. This is a radius of 0.1. Remember the size of the voxels that we had, right? I'm just gonna let this animal move a little bit further. Let it come in. Okay, let me find a frame. All right, cool, something like this. Okay, so right now here we get the particles with a radius of 0.1. I'm gonna grab the container and I'm gonna set it to bottom once again, so we can illustrate what I was talking about earlier. Now look at the size of the particle, look at the size of the voxel. They're almost the same size. This is what it looks like. I don't know, exactly the relationship, but I can easily tell. This particle feels too big for this voxel. It's going to fill it in right away. So it's not really the case. I'm going to go a little bit slower on my particles. .05. Rewind and play it back. Okay, these are 0.05, a bit more appropriate for the size of the container. Like I said, this is a case where having particles set as spheres is just a way to visualize the radius that I'm going to be using. So 0.05 is good. I'm going to put these guys back to points, and I'm going to go to the expressions, and I'm going to set my radius per particle. Okay, radius per particle is equal to a random number between 0.0, let's say 3 and 0.06. Okay, perfect. So I get particles that are a little bit smaller than that, and well, not that these are points, what we had before, and a little bit bigger. So make sure that 0.05 is within range. You can probably go something like that, maybe. Excellent. So now I get particles with radius. I can go back to my fluid emitter. I can now activate this option. So Maya will include the radius of the particle into the calculation. Rewind is always it's good to save in these cases. Saving, I'm going to get rid of the display. Set it back to bounding box. Okay, I have my emitter over here, and let's talk about emission. The important bit here is to make sure that you're emitting velocity, but also there's no fluid simulation without density. So those are the two things that you need for sure. If you don't have density, then you get nothing. If you have density and don't have velocity, then what's the point of the exercise? So what I mean by this, I don't need heat, I don't need fuel, I need density, which is fine. I'm going to set it to 1 for now and see how it goes. And I need to emit velocity. Before you do, motion streak needs to be activated. I explained that a little bit on the previous lesson, but I'll tell you again. Every single time your emitter is moving, the motion streak needs to be activated. Motion streak is going to make sure that between the position, let's say in this case, the position of the particle in frame 1 and frame 2, in between those two frames, there's going to be density being emitted. It's going to help you doing that, and then it's going to avoid having those almost like dotted line that we used to get before when an emitter was moving too quickly, and probably between frame 1 and frame 2 travel, over 3 or 4 voxels. Then you will get empty voxels in the middle. It was terrible. So now you don't have to worry about that as long as you activate motion streak. So a rule of thumb is if it moves a little bit, the emitter, then activate that. Emission turbulence, it's all right to put it, but don't put too much. I think 0.1 is fine. I want to make sure that I read is the speed. Speed method, as you saw before, we have add and replace. Add is as a number, as the name tells you, you're just adding the velocity one frame to the next. And replacing is just setting the velocity on that particular voxel to whatever number you have set over here. It's a more abrupt, more immediate result, the replace to the add. So I'm going to use that actually. I'm going to use replace because I want to make sure that those velocities from the particles really influence the container. Inherit velocity. How much velocity do I want to inherit from this guy? I'm going to start with 100% and see how it goes. So 1 is 100%. That's all. That's all I have to do as far as emission. Now we go into the container, which is over here, which is disabled at the moment, but it's okay. I'm going to save. And what do we need? First of all, the boundaries. We need to have them all closed, all open. How come? All I can say is that it will probably be best, and that's my decision. You probably think of something different. The only thing we have to agree, you and I, is that the bottom part of the container has to be closed. That's the floor. If you open it all, and this guy enters, okay, it's going to be emitting density and velocity, which is actually probably going to be coming this way, right, towards the bottom of the box. If it's open, then all the density and the velocity is going to escape through that. You don't want that, right? That doesn't really happen in real life. You want that air to bounce off the floor and come up and swirl towards the camera, towards the back. So having that boundary open is a big no. Always close. Now, what do we do about the top one? And the front one and the side ones, right? Well, I'll leave it up to you. I'm gonna try one and see how it looks if I open. Okay, having boundary X none, meaning that on the X axis, which is the sides, okay, there's no walls. Having boundary Y as negative Y, meaning that the bottom part is closed and the top of the container is open. And in Z, I'm gonna set it to none, just to see how it goes. This configuration means that this box is open everywhere but the bottom. I don't know, we'll see how that goes. I'm calculating density, of course, velocity, yes. I don't need temperature or fuel. That's perfectly fine. On the display side, I think we're okay for now. Dynamic simulation, the usual changes. High detail solving, of course, that should be on by default. Solver quality, I'm going to go to 200 right away. I want this thing to look really nice. I'm leaving the rest as it is. As you can see, there's nothing. The less you change, okay? Try to keep it simple. I know I repeat myself a lot, but that's the most important thing. Keep it simple. Don't start mixing viscosity with damping and friction without even seeing how it looks like. Wait. You're dealing with air. Air has to be free to move. It's thin, it's light, so definitely not viscous. I'm not going to be dealing with any of that. Damping, none of that. It's going to confuse you more. Keep going. No liquid, no auto resize, no self-attraction. Open content details, you get density. You want the air to move up. Buoyancy of 1 is normal. Think of something. If you're dealing with air, that's almost like the default settings of the fluid container. It's made to simulate that by default. So you don't have to change too much. Buoyancy to 1 is fine. Dissipation, yes, absolutely. I'll have some of that. I'll put it to 1. And I won't touch anything else. Velocity, very, very important. Swirl. I've seen some of you do your first fluid simulations and don't use the swirl. And like I always say, you always need it. If you don't have swirl, you don't have eddies on your simulation. And almost every simulation need it. Then you need the eddies. You need the particles to rotate, around, let's say, a voxel's axis. And just almost put it that way. So no swirl means no go. I'll start with 10. I don't know. Like always, I'm not reading a recipe. I'm just thinking. I'm thinking because the swirl is related to the resolution. I'm using a 4:1 ratio. 10 will be a lot of swirl. Will be fine. If I ramp up the ratio on the resolution, I might need to go higher to 16, 18, 20, 24, almost sometimes. It will depend. I think in this case 10 will be fine. If you go too much, then it will become noise. It might destroy the nice movement of the particle. So I think 10 will be fine. Turbulence on the container, I'm going to leave it off for now because I have already turbulence on the emitter. Too much turbulence then again becomes noise. You want to be able to read the air. So don't mix it too much. It's not an explosion. And to be honest, man, nothing else. Especially not the shading part. I don't need to do anything, lighting, textures, or shading quality. Nothing is needed because it's not going to be rendered. So I'm done. I'm going to re-enable my container. I'm going to save it. And I'm going to run it. I'm not saying it's going to look perfect the first try, but let's see. It's going to be a little bit slow. And it's the next thing we need to talk about is why do I need to have a container being simulated if the emitters are not even close to reaching it? So once again, I'm going to rewind. I'm going to disable my container, and I'm going to judge which frame is my particles entering the container. Because I don't need the container active anytime before that. So I'm happy here. I'm close. I'm in frame 63. So I'm just going to grab my fluid container. I'm going to go into dynamic simulation. And the start frame is set to 1. But now it's going to be set to 63 frames. Don't activate it right when the particles are entering, or don't activate it after the particles enter the container. Activate it 1 or 2 frames before. If you do it after the particles enter, then the simulation begins. You have emitters with velocities already inside. It could look funny. So make sure that you do it just a couple frames before. How will this help you? Well, it will help you because it will save a lot of time. On the first 63 frames, it will be useless to have a container active. When the time comes in, then it slows down. Remember, these are things that you will be repeating over and over and over again. And if you say, for example, let's say a minute or 2, okay? If you do this 100 times a day, it's close to 2 hours, man. Those are the 2 hours that you're going to be home watching your favorite show or eating or being with your family. Simple. It's a very simple detail. If you miss it, you'll be at home later than you should be. So, it's very, very important. Just a simple number translates into so many different, has so much impact in your life. It's amazing. You will be doing this 100 times a day. It's a fact. You'll be changing values and doing it again. You have multiple shots. So, every single little bit matters. Okay, so simulation is running. I'm starting to see something. You see, there's a bit of density here, but not really enough. Let's just pause it and judge. Okay, I see something in here. it's a bit difficult to see, to judge what's happening inside just by looking at a little, spiff of density. What you really want is to look at the velocity vectors. I'm just going to grab my container, go to the display tab, and the velocity draw, I'm going to turn it on. And this is what's going to tell me what's happening really in here. It's a bit heavy on the arrows, on the vectors themselves, so I can just probably skip a few. Make them a bit longer. This is a cool trick. If you make them, if you play with the velocity, the draw length, I'm sorry, which is the length of the vector itself, I like to go back and forth, okay? This tells me, it's almost like a time machine. It's telling me where the particles or the velocities are going, where they're coming from, just by making this vector longer. So I can see, okay, this velocity is pushing down at an angle. It is working. It is emitting velocity. So at least that is being passed on. I like the fact that the velocity is close to the body. What I mean by this is that the vectors, as you can see, they're being affected closer to the object, nothing down here yet. That's good. So I'm happy with that. I'm just a little bit low on the density. And you may think and you may say to yourself, well, why do you worry so much about the density if you're not going to be rendering the fluid? That's a valid question. I worry about it because the density at the end is the air itself. So I may have velocities being shoot out, but if I don't have any density to carry, then the particles are not going to be moving. The particles move because of the density, and the density moves because of the velocity. So all things are connected. That's what I say, that you cannot have this simulation without density. Just with velocity, it's not going to work. You could emit it, but there's no point. The velocity gets carried out by the density, so that's why I'm happy with the amount of velocity, but I'm not happy with the amount of density. And it has a lot to do with the fact that the particles are small. It also has to do with the fact that I have only 3,000 particles, probably need some more. And the third cause of this is the radius of the particles themselves. So you have to decide, where do you want to put your money? And I think adjusting all three things is the most sensible of all. So first thing I'm going to change is my particle radius. So I'm going to go back here and I'm going to increase it a little. Let's just say 0.5, 0.9, something like that. That's good. That already is going to be translating into more density. So I'm just going to save it and show that to you. I changed one variable only first. Okay, you get your particles coming in. Container gets activated. Things are slowing down. It's good to have it 1 or 2 frames before. In my mind, I see it as the container is resetting and preparing to receive the new values. And actually, that's what's happening. Okay, so let's see. Again, at home, I probably have to do that now, but we'll see. You will need to probably work with a smaller ratio. 4:1 is good. Probably 3:1 will save you some time, and we know that it's important. So, in my case, I think I should probably because the recording, right? I don't want to make you wait longer than you should. But let's see. Let's just take a look. Look, I just made the particles a little bit bigger, and you already see density, more density. And this is a perfect proof of what I was trying to say earlier. Particle radius, it has a direct impact on the amount of density being emitted. My advice is to do what I'm doing here. I'm adjusting one thing at a time. I'm making the particles a little bit bigger, and I'm happy. Okay, I get more density. That's good. The next thing I will probably do is to have a little bit more particles, just for fun, just to show you how you could. Let's just add 1,000 particles. That's it. That's the second change, and just to save time, I'm going to do the third change, which is emitting a little bit more density. So I'm going to the fluid emitter, and I'm putting 1.5 as my density. I'm also going to increase a little bit the amount of velocity being inherited. That's all. That's what I'm going to do. I'm going to save my scene and run it again. And I'm going to show you another way that you can speed up your process of simulation a little without compromising your quality. You can just grab your shaded display and set it to off and run it. It's going to run a bit faster than what you had before. And you can already see it. There you go. Setting the display to off is a good trick, and I always do that, and I advise you to do that if you're going to be doing especially fluid caches, for example. I'm not rendering this fluid, yes, that's fine, and the shaded display has nothing to do with the simulation. It's just you're telling Maya, don't to worry about drawing this thing because I don't want to see it. You will become more comfortable with fluids, and sometimes you work without looking at the result. You just cache it or render it and then look at the render result. It's faster. Look how much speed I'm gaining. Hard for me to calculate, just eyeball it, but I'm thinking probably 100% increase in this particular case. So very, very cool. If you want to see it, okay, if you want to, you can stop the simulation here, right? And just switch it back to as rendered. And there you go. There they are. But it's faster, right? So I go in, set it to off, and continue. Let it run. All right, here it goes. So when you cache in your fluid, you do your testing, set your values and all. You're happy with everything. Set it to shaded display off, and then just cache it. Let it run. You'll gain a lot of speed in that way. Okay, so I'm just gonna quickly take another peek. I'm thinking that I'm a bit light on the density still. I'm trying to stop this. A second. All right. It's a cool way to stop the fluid is to have it selected and hit escape. I think it's almost like it's to get a faster feedback. It will stop faster. As if you have nothing selected, you hit escape, it might take longer to cancel the simulation. Okay, so I'm good with the density here. I'm gonna check my vectors, and they look pretty cool. Very good. You see? So what I'm doing, if you move it back and forth, you get the idea of what's happening here. They're starting to arc, starting to hit the floor. Excellent. All right. Look at it from the top. This is where the money's at, man. This is cool. Look at each wing. The wing from this one is arcing towards the inside. This wing is arcing towards this side. It's going to be colliding in here and colliding with the floor. This looks awesome. Awesome, awesome, awesome. I like it. Okay, this is good. I don't need to go all the way to the end of the simulation to realize what's happening. I feel confident in what I do. Of course, I've been doing this longer than you. That's why I'm teaching you this. You probably should run it more and take a look and see. I'm not a big fan of caching fluids. If it's not really for rendering, it's not really necessary. But if you have space in your hard drive, just run it. Run the cache. You'll be fine. You'll be faster. But try to, once you become more comfortable, try to trust what you have. What I can see here is enough for me. At least for now. I don't know if probably I can just turn the velocity off, turn the display to off, and let it run a bit more while I'm telling you these things. But it's a good idea to start to, as soon as you can, start trusting your, yourselves and what you know. The only reason I would run this longer is because I have the time, because I'm telling you these things, and second of all, because I would like to see if the dissipation is enough, or if it's too strong, right? If the density is dissipating too strong. But I think it'll be okay. You will get a lot more density, and try to think of it this way. You will get a lot more density probably at the end of the animation when it's flapping its wings faster. Probably get a lot more, velocity there. Because of the, they're moving back and forth quite quickly. So try to think of all those details, right? So if you have too much velocity here towards the beginning, where it's entering the container and it's moving slowly. Once you get to the bottom here, you will get a lot more velocity. So, well, you have to see if what you have is right or if you think it's going to be too much. I trust this thing. So let me just pause it. All right, you see, because I have my fluid container selected, I hit escape and it's faster, right? It stopped faster. So that's another thing you could do. Velocity draw, very cool. Nice vectors. And density, turn it off. It's actually a bit light, as you can see here. It's a bit light. I would like to see a little bit more density. So I'm just gonna go in and add, I'm happy with the inherent velocity, so I don't have to touch that. I'm just going to go probably to 2.5 on my emission. And I'm done. I don't have to cache it. I mean, I have to run it again. I'm gonna set it to off, rewind, save. And I'm going to disable the evaluation of this. And I'm also going to disable the evaluation of the particles for the velocity. Why? Because I'm going to be focusing now on the ash itself, which is on the ground. So good there. I'm just going to make a simple, this is so easy for you now. It's almost dumb to teach it again, but hey. All right, here you go. I'm just going to make myself a little plane. Something like that. Good. Okay. Here's my plane. I'm going to move it up a little. I'll place it later better, but I just want to be able to see it. I'm going to add a material to it. An existing material. You've done this many times before, so it's not a problem there. Assign a favorite material, just a Lambert. This Lambert I have already created here. If I'm not mistaken, I actually have the material already. This one here. So I'm just going to assign this material to the selection. It's easier. There we go. You know why this is for. I want to use this texture for the emitter, that's all. Grab the plane, go to end particles, emit regular particles from it. Surface, hit create. Okay, this particles is going to be called ash. These are the particles you're going to be rendering. So they are important. Very cool. Grab the emitter and connect the texture to it. So going back to the hypershade, going to my textures, and dropping the noise, which is the one assigned to that, dropping it into the texture rate, enable it. Cool. I don't want any speed on that emitter. I want the particles to be born and stay where they are. And I'm going to put quite a bit of particles. So let's say start with 5,000 particles. These particles, I'm going to make them, well, for now I'm going to keep them as points just to see them. And I hit play. Nothing special, right? By the way, look at the texture, right? From the wings of the butterfly. All right, cool. So there are my particles, 5,000 of them per second. You will decide later the right quantity. This is just too simple to spend too much time on that. I'm just gonna place this thing where it should be. Make sure, okay, don't place the emitter outside of the container. You know this already. Don't do it because the particles will be born outside and you won't get any motion. You have to place it a little bit inside, just like that. Particles have to be inside. These particles, we can do a couple of things to them. One of them is grabbing the conserve and setting that to 0. We talked about it earlier. If it's 0, then you're going to be passing on, full influence of the container onto the particle. So the particle will move if it's inside the container and if that container has velocity and density. Otherwise, it's not going to move. The moment the particle crosses that line, one of the boundaries, and they're open, so they will cross it, the particle will stop. If they stop, then you have to make a decision. If they are streaks, they won't be visible. You could kill them if the velocity is 0. It's up to you. I'll leave that up to you if it's necessary. Don't go and overcomplicate things if it's not needed. But conserve has to be 0, that's for sure. I'm gonna set them to streaks. And I'm gonna have them live forever for now. Save it. Done here. And I'm going to re-enable my container. And I'm going to re-enable my velocity particles as well. All right, I'm going to save this, be done. These particles here could be emitted later as well. So the start frame, they don't have to be emitted earlier when there's no fluid, right? So I'm going to do the same. I'm just going to start emitting them on frame 64, for example. Okay, very cool. And if you hit play, let it be. Okay, we'll see. Being that there are streaks, you should be able to see them only if they're moving. I like it that way because it will tell me if the influence of the wings is too strong. For example, if I start seeing particles move at this point, where the animal is outside the container or half the body is outside and it hasn't really flapped its wings inside, if I see them moving right now, we'll see that probably I'm inheriting too much velocity from them. I'm putting too much velocity into the container. So, something to keep in mind. I'm doing this on purpose. I'm hoping that some of you might notice what is missing or what my mistake is. Still nothing. Particles are not really seen at the bottom. I have them selected, if you see in my outliner, just so they light up green. They're there, they're moving. And nothing. Okay. How come? How come is simple. I'll give you a second to think. Why are not moving? They should be moving because I have velocity, right? You'll think, well, but no, there's no really velocity yet towards the bottom, and that's true. So let's see, let's wait a little longer. Maybe when it gets closer, it will be visible. Let it run a little more. There's one step that is not really, hasn't been done. Another thing that we could do once we let this run a little longer, these particles, as pretty much any simulation we have done, we need to randomize the mass. We shouldn't just assume that all the pieces of ash have the same weight, because that's not right. They don't have the same size. We need to randomize the mass. That's a given. That's for sure. Now, why I'm not seeing them yet? Well, that's a different story. I'm just giving it a little bit more time to get closer to the ground and see if that's the reason. But one thing is for sure, there's density inside this container already. There's velocity, and that velocity moves, and it should be visible even a little bit. I'm gonna pause this thing one more time. This banshee is a lot closer to the ground. Let's see. Trying to pause this simulation. So to grab this container and pause it. Okay. Activate velocity draw. Definitely I have velocity now hitting the ground, the bottom part, and still no particles visible. I'll use this opportunity to look at my density. Cool density, I have it, but I have no particles. And the reason is because you have to connect them to the force. It's like creating it's like don't have anything selected. You create for example, now a turbulence field. It's not going to be connected to the particles. It's the same way here. So you need to go into the relationship editors, dynamic relationships, and then connect the particles from the ash to the field, which is the fluid shape in this case. Now they're connected. Now that we're here, I might as well go in and change the mass of those particles. Simple stuff. Okay, and I'm going to run it one more time. This way now I'm going to keep an eye on the fluid itself. I'm going to grab this emitter and I'm going to place it on a layer. Okay, that's the layer for the floor. I'm going to create a new layer and it's good to name it and hide it. Okay. All right, let's run it. You see how important it is to set your start times at the proper, proper frame, because you're saving quite a bit of time. We haven't done this 100 times in this lesson, but we have done it at least 6 or 7 times. So it's helpful. While this is running, we can say that that shot has ash in the air also. I'm not going to do it in this lesson because it was done on the previous one, but you should probably add it. So combine, like I said, combine lesson 21 with lesson 22 on the assignments and get something interesting where Jake and the Banshee are moving them. If this works, it probably marks the end of this lesson. We'll see how this goes. Don't forget to connect them. That's the thing. I think I have my display activated because I think I see some density here. So I'm going to make sure that I stop this and I verify. Yes, my display is set to as render, so off. So this thing will go a bit faster. That's good. Okay. We'll keep an eye. I'm starting to see something here. I'm going to grab the ash. Take a look that even the simulation is running. You can still, in between evaluations, you can have selections here. So I know I clicked on the ash. It will eventually be selected. If you want to make sure that it's done faster, then yeah, you're going to have to pause the simulation. Okay, grab these particles. You can see them now, right? They are. I think it'll be easier this way. All right, let them continue. So yeah, combining the two assignments, I think is going to be the best way. Another thing you need to think about is, what happens in real life? Do you want the emitter from the ash to be emitting constantly? Probably not. That's not what's happening. What's happening is the environment is filled with ash, and this is going to move in and displace it. I'm saying that because I can see here that the wings are clearing this area, but then it gets filled up again with new ash. So I don't like that. I'm going to stop it. What I would like to see is just the ash here being displaced and having an empty space here. So having an empty area of the ground with ash because it's being moved forward. So it's definitely working. You can see it now. But it's not really realistic. It's not like the ground is emitting all the time. So let's try to pause this thing again. Cool. So I'll do a different thing. I'm just gonna see now I have about 4,500 particles in here. So I'm just gonna say, I don't know. Let's say that I have 6,000 particles of ash just for the sake of the speed of this lesson. You probably need a lot more than that. I'm just gonna put 6,000 as my max count and have them being emitted a bit faster. So I don't know, just put this to 50,000 particles just so I get them really quickly. Yeah, you know that already. Grab that, rewind, save it, and one more time running it. When this is running, the mass of the particle, whatever mass you're placing on your expression, it will have an effect. Okay, the particles are heavier. They're going to be harder for them to move inside the container. because there's not really a magnitude value. It's not, we're using the field, the fluid as a field. And every field, as you saw before, you have magnitude. That's an easy way to control how strong that relationship is going to be, or the influence of the fluid. It's not going to happen with this. I should rephrase what I said. Having a magnitude on the field is going to be an easy, is a way for you to judge the influence of the field on the particle. That's what I wanted to say. With the fluid, it doesn't happen. There's no magnitude. So you have tools on your, that help you play a little bit with that influence, and one of them is the mass. So I'm saying this because we don't know yet, but we'll see if I have a hard time moving these particles around. You could lower the mass and make them a bit lighter so they're more susceptible to the wind that is generated by the wings and the container, right? That's one solution. The other solution, which is probably best, is just to emit more density. When I looked at the density earlier, I saw that it was a bit tricky to see, so it was a bit light. So probably a little bit more. We'll see now. Still, this animal is further back, so I think we still have time to see. They're definitely moving. So as long as you see this green, stop that for a second just to get a better framing. If you start to see them green, means that they're moving. They're moving is good because they're connected. It's just that you don't have enough velocity towards the bottom yet, and it's okay. Just try to stop this. All right, just to try to get a better framing. Just to see when it's gonna be, starting to move up, something like that, I would say. Another thing to keep in mind is we have a container. That's what I said that I wasn't sure, but we have a container with open boundaries but the bottom. That helps to, for the density to escape. And if the density escapes, then you get less influence on the particles, right? So it's a dance between the mass of the particle, the amount of density you emit, the boundaries if they're open, if your dissipation is too high. But it all translates and all sums down to seeing the density inside the container. The density is what is going to move the particles. No density, no motion. Just as simple as that. So in this case, you can see they're being pushed forward. That's good. But they're not rising. I would like to see them rise up. But now it should be enough air for these things to move and start to curl up and have a lot more movement here. I'm not really enjoying this too much. I'm just going to stop the simulation. All right. 1 second. I'm just trying to kill the simulation here. Come on, man. It's annoying when the computer gets excited and doesn't want to stop. So you see, I deselect the container just so I can reselect the heat escape again and see if Maya understands what I'm trying to say to stop. We'll see. It will be worse. Okay, now it stopped. It will be worse if you have the display set to on. This is not really appealing, at least not for me. It's not really what I saw on the shot itself. And if you watch something like that, then why do I have to need? What do I need such a big container and why? Right? That's not really what I want. But before I rewind and hit play again, I need to make sure that I understand what's going on. So, as far as the velocities, they're okay. I think what's killing me is the density. And yes, it is. It's not enough density. I should have density on the front already here. So I'm going to push the boundary, the limit a little bit more. So what I'll do is close this container, first of all. I'm going to close it everywhere. one thing. Probably go too far, but I'd rather do that to save time. So I'm gonna go to, let's say 4 on my emission, and I'm going to do 1.5 on the velocity. That will give me a lot more density. The density won't escape towards the bottoms and all that. I'm gonna go to 5. Okay, good. And probably, no, I think I was gonna put more particles in there, but I think it's gonna be okay. So that's good. Select the container, go to off on the display, save it, and run it one more time. I could pause the lesson and save you time for you watching this thing move, but I don't know if I'm not. In this case, I wouldn't want that because I really want you to start seeing the particles move. So if I pause it now, we'll have to come back in just a few seconds, and it's not really worth it. Just bear with me here. I don't want to lower the resolution also because it will mess with the size of the particle versus the size of the container that we talked earlier. So it's not really the case either. We just need to be patient, that's all. I can see already they're starting to move. That's good. When you do the assignment at home, you will this type of feedback, okay, this speed that you have here of simulation. I'm saying the way it moves from frame to frame for a final shot is not right. Okay, this is gonna take time for sure. This simulation is gonna be done in a few, couple of hours or something. This means that probably not. It means what it is. It's just not enough particles go to the wings. Okay, so not enough resolution on the container, not enough particles of ash. And that's going to be the main thing. You need to have a lot of particles here if you're introducing ash in the air. So also you're going to have more particles there. So it's going to take a bit of time. I'm doing this quickly because I don't want to make you wait here. But I'm expecting from you something with a lot more detail than this. So we should have now a lot more density. Density is not escaping. It is dissipating. I didn't mess with the dissipation yet because I think it's not really necessary. But we'll see. We're also emitting more velocity. So those vectors, once we display them, they should be longer. A lot longer than what we had before. When you run your simulation, make sure that the ash, is you put some transparency, you mess with it a little bit. Just make it look as good as you could. You could probably, I think it'll be interesting. I'm just, thinking of ideas while the simulation is running. You could inherit the color, and it's always in the spirit of combining everything you learned so far. So what I would do probably is grab a picture of ash, or just not one. I don't even know how a flake of ash. I don't know how you call it, but I wouldn't grab just a picture of that. I just grab, for example, a field covered with ash, right? So something ash on the ground or whatever. It's morbid, but almost like a cremation, like a pile of ash, like that, something like that. I will grab probably an image of that, map it to the emitter itself, use that as your emission, probably not the emission pattern, I don't know, but yeah, we'll use it definitely to inherit the color. It's faster, so it will give you variation on the tone of each of the particles, and you know how to do that from the first lesson. Inherit that, add some opacity to it, so have a go on making it look cool. Always keeping in mind that the purpose of this exercise, of course, is a fluid, but you have to present it in a proper way, right? So help yourself with that. Okay, I'm going to pause this because I'm still not happy with the amount of, these things are not moving enough. So I'm going to pause it, hopefully. everything in Maya, you know, you have to be patient, especially with fluids. You have to be patient. Okay, so it stopped because again I'm seeing some motion in here, so they're you know rising up a little, but it should be happening on the front already. So let's render. Yes, I have more density, but not enough. Velocity, it's a bit weak. It's a bit weak. So I'm not gonna mess around because I'm wasting way too much time on that. So I'm just going to go into my emitter, and like I advised to some of you, I'm just gonna break it. So I'm just gonna double my density, double my inherent velocity, and I'm going to add a bit more particles of the velocity on the wings, I'm saying. So 5,000 on that. Shaded display is off. Those are my values. I'm going to save it and I'm going to pause the recording for a second just to let it run a little bit. Okay, so I'm going to initialize this and pause it. Okay, so I let it run for a few frames and I'm still not happy. Look, it is, you know, they're moving. You can see they're the air is definitely affecting them. You can actually see some of here, but I would like to see them climb up. So let's take a look and see how the container is looking. That's my density, so you get a lot more than before. That's good. But I wish it would be, you know, a bit more further out and starting to climb up. My velocities are better. Okay, they're better, but still needs more. We're having to change it a few times because we're using the radius on the particles. If the particles were bigger, then it would be a lot easier. But it's not a problem, especially if we're pausing the recording. So density, I'm going to double it once again. Inherent velocity also, I'm going to double it. Rewind. And I'm going to run it one more time. You save it before you cache it. So before you run it. And let's do it again. So I'm just going to play it back, pause it. I'll see you in a minute. Okay, so I let the simulation run and much better. Okay, so you can see already, you know, the particles are not stuck to the ground. They're starting to move up. Anyway, let's just check our density. So I think I probably went too far with the amount of density, but it's correct on the front. I think I'm happy with this. Probably should dissipate a bit faster, or we can open the boundary on the top to let, you know, this density escape. As far as the velocity goes, let's just take a look. Yeah, it works quite well. You get nice turbulence on the back, you get direction on the front. That's good. If you wanted to get more particles to climb, okay, to get more of an arc right here, then probably increase the buoyancy a tiny bit. Just that will make the particles rise up a little bit faster. You could, like I said, you could reduce the mass of them. A random between 1 and 2 could be too heavy for this. It's up to you, depends. Either way, you can do the mass or you can just increase the buoyancy. That'll be fine. But here you can see that you can translate now the particles velocity into the container, have that velocity move particles so you can interact and have atmosphere into this. We use the same technique in many films. We use on Pacific Rim, where the characters are walking, you know, the kaijus and the robots and all that, they're walking because it was a rainy environment. We needed to have some sort of turbulence. So having this pass, as you can see, meaning the fluid container, we used to run that as a process, a pre-process, and every simulation had it involved. Every single one. Having atmosphere is key for a big film. As you can see, something that is cheap, something you can do quickly. Definitely something you can do at home. So why not involving this kind of film-like, let's say, techniques into something like a commercial or something for your client, it will definitely step it up, because getting that result with a field, just a regular field, is extremely complicated. Just because I don't want to say impossible, because well, I might be wrong, but um, nothing like using a fluid to make something look cool and integrated. So, well, like I said, I'm gonna upload the FTP, then the scene file with the butterfly, the ground, and the camera. The camera, by the way, is this one. Okay, so you get a front view of the thing, similar to what we had in the reference, so the particles can kind of come sweeping towards the camera. So, work that out as well. If you don't want these particles to be visible, the ones on the wings, on your play blast, is extremely easy. Just add opacity per object, set that opacity to 0, and then that way you don't have them. They're involved in the simulation, but you don't hide them, because they won't be included in the simulation. So just make them transparent, so they're not, you focus on these ones. Just to say, they're visible on wireframe is normal, but on shaded view they're transparent. So as you can see, they have nice height, nice turbulence. You can see the curvature due to the swirl. So I'll look forward to see this plus assignment for lesson 21 all into one scene file. So with that, thank you very much, and I'll see you in the next lesson.